Hi, welcome to Sound Waves 101. I'm Mitch.
And I'm Farron.
Sound transmission. An object's vibration propagating waves through a medium produces sound. Sound can be heard by the frequency it produces. The higher the frequency, the higher pitch the sound. Sound can be transmitted through any elastic medium such as air, obviously, but also water, earth, and plasma. The density of the medium is what alters the speed at which the sound is transmitted. Therefore, sound travels faster in a medium that is denser.
Sound transmission. Sound waves are created by disturbance that then propagates through a medium. Transmission of sound waves occur when electrons in the object that is the sound source begin to vibrate and cause the waves to be transmitted through the air to our ears. Then, our ears and brain process the sound information. A sound wave will continue to bounce around the room until it has lost all its energy. Depending on the frequency of the sound will depend on the pitch. The higher the frequency, the louder the pitch. Also, the less dense the medium, the further and faster the sound will travel. For example, whales can communicate over vast areas by calling out to each other underwater. Water is more dense than air, so the whales can transmit sound waves underwater many times further and faster than in air.
Sound reflection. Reflection of sound is when sound waves rebound off a given surface. Depending on the shape of the surface, the sound waves can be directed in a certain direction. The phenomenon of sound reflection is called reverberation. For example, when a band stops playing in an auditorium, you can hear the sound ringing in the room as the sound waves reverberate off the walls until they eventually dissipate. Echoes are also caused by sound reflection, as the sound waves produced by your voice bounce off your surroundings.
Sound reflection. The reflection of sound waves follows the law the angle of incidence is equal to the angle of reflection. Reflection of a wave is the change in direction of a wave between two different mediums so that the wave returns through the original medium. Echoes are the sound of your own voice reflecting back to your ears. For example, a bat uses echolocation to see at night. They send out a sound wave and it reflects off objects so they can determine how far away an object is.
Sound refraction. Sound refraction occurs when waves change mediums. The sound waves change direction slightly when crossing from one medium to another, but do not reflect back. When the sound waves refract, the frequency does not change, only the direction. When sound refracts, its speed is either speeding up or slowing down depending on the medium. When sound speeds up, the sound bends to the left. When it slows down, it bends to the right. Refraction can be compared to driving a bulldozer or a skid steer. If you slow down the right track, the vehicle turns to the right and vice versa. The same thing is happening with sound refraction.
Sound refraction. When the sound wave changes its angle or direction, refraction happens. When the sound wave enters a medium of different speed, the wave bends and refraction happens. A sound wave can change direction and there is a change in speed, causing the wave to bend away from its original direction. Sound waves travel in a straight line until something interferes with its path. The speed of sound is faster in warm air and slower in cold air. This is because of the molecules of air moving faster and the vibrations of the sound wave can be transmitted faster. An example of sound refraction is the sound of thunder that is created by lightning may be refracted upward so strongly that a shadow region is created in which the lightning can be seen but the thunder cannot be heard.
Sound diffraction. Using the edge of a barrier, sound diffraction creates a secondary sound source. When combined with the original waves, sound can be heard around corners and across an entire room. This is why you cannot hear your friend very well on the other side of a wall, but if you open a door, sound traveling through the wall along with sound traveling around the corner and through the door can be heard.
Sound diffraction. Diffraction is the capacity of a sound wave to bend around corners and to spread out after traveling through small spaces. The ability of sound wave to diffract decreases as frequency rises and wavelength shrinks. For example, when you hear a muffled sound from around a corner, it is because of the lower frequencies of a voice bending around a corner faster.
Partial sound reflection and refraction. This occurs when some of the sound waves reflect and some of the sound waves refract. When the sound waves change medium, some continue on in the new direction and some reflect back. The reason you can only hear someone a little bit through a wall is because most of the sound waves reflect back and only a few can refract through the medium.
Partial sound reflection and refraction. Partial sound reflection and refraction is when part of the sound wave is reflected and part of the wave is refracted. When a sound wave travels from different mediums, part of the wave is reflected and part is refracted. If a sound wave was traveling from a medium that is traveling much faster, such as air, into a medium like water where it is traveling slow, when it goes into the different medium, part reflects and part refracts. For example, when a highway travels by a subdivision, there are sometimes walls. Most of the sound from the vehicles reflects back away from the subdivision, but some refracts into the subdivision. These walls reduce the sound traveling from the highway to the subdivision by partial reflection and refraction.
Sound interference. When sound waves from multiple sources interact with each other, it is called interference. If the waves' compressions and refractions line up, they can create a new, even stronger wave known as a constructive wave. When their compressions and refractions do not line up, they can create a lower, less intense wave known as a destructive wave. If you have two identical waves, they will completely cancel each other out, eliminating any sound that is produced. Auditoriums are designed so that there is no interference between the sound waves produced by the band.
Sound interference. Sound waves travel in many directions, and it carries energy while it's traveling. If a sound wave is traveling in one direction and there is another sound wave in the other direction, they interfere, making nothing, no sound. When two or more sound waves from different sources that are traveling in the same medium are present at the same time, they interfere with each other and produce a new wave. The new wave is both of the waves put together. For example, when you are talking close to someone, but there is a load of destructive noise in the background, both sound waves are interfering, making it hard to hear the person talking to you. Through small spaces such as holes or slits. The ability of a